Hey everyone, welcome back to the channel. In this video, we will discuss the basics of graph. This kind of data structure is something which we called graph. It contains nodes. These nodes are interconnected with each other. For example, this structure has 1, 2, 3, 4, 5 nodes. And this one node can be connected to at max n minus 1 other nodes. 1, 2, 3, 4. The maximum connections that one node can have. So this type of structure in which nodes are interconnected with each other is called graph. Tree structure is also a type of graph only. So let's first check what are the parts of the graph. So as I told you already, this is a node. But we do have a connection between two nodes. This connection is called the edge. There can be undirected graph and a directed graph. So what do we mean by the undirected graph? Let's say there are two nodes, U and V. In undirected graph, if U and V are connected with each other, that means we can go from U to V and we can go from V to U also. So it's a both way relationship. But in directed graph, for example here, we have directed the relationship from 3 to 5, from node 3 to node 5. That means we can move from 3 to 5, but we cannot move from 5 to 3. So the relationship is directed. So when the relationship between nodes is directed, it is known as a directed graph. Otherwise, it is an undirected graph when we can have movement in both the directions between any two nodes if they are connected. Now, based on the structure, we do have cyclic and acyclic graphs. What do you mean by cyclic graph? For example, in undirected graph, we have this type of a structure, this type of enclosed structure. If this type of enclosed structure is there, then we can say this is a undirected cyclic graph. That means if we start traveling from node 1, let's say we go to node 2, then from 2 we go to node 4, then from 4 we go to node 3, and then from 3 we can again come back to node 1. That means we can come back to the starting point again. That's why it is a cyclic graph. There can be acyclic graphs also. Let's say the structure is not enclosed. So for the undirected graph particularly, if the structure is not enclosed, then that graph will be acyclic graph. For example, this. Since this structure is not enclosed, let's say we start from node 1, we cannot come back to node 1 without visiting any other node again. So from 1 we can go to 2, from 2 we can go to 3. But to come back to 1 again, we have to again come back to 2 first and then to 1. Hence, it is not a cyclic graph. So particularly for undirected graph, we can say that if the graph has an enclosed structure, then we can say that the graph is cyclic graph. Now let's discuss the directed cyclic graphs. So as in this structure itself, let's say we can go from 1 to 2, we can go from 2 to 3. Can we go from 3 to 4? No, we cannot go from 3 to 4. Hence, it is not a cyclic graph. Can we find any other cycle? No, it is also not a cyclic portion. If we can find any one cycle structure in the graph, then it is a cyclic graph. So here, let's say we change the direction of this edge and it became 5 to 4. We can say that it is forming a cycle. And we can say that it is a directed cyclic graph. Cool. So this was about the undirected graph and the directed graph and the cyclic and the acyclic graphs. Now let's discuss about the weights in the graph. So here, if we say that if we move from node 1 to node 2, the weight of this edge is 3. That means, let's say city 1 from city 2, the distance is 3 kilometer between these two cities. Let's say the distance between city 2 and city 4 is 4 kilometers. These are just some random numbers. Cool. So what we can say from here, if we want to travel from 1 to 4, the total distance becomes 3 plus 4 is equal to 7 kilometers. Cool. So by default, if there is if in the question it is not mentioned anything, then we can consider the unit weight. That means 1. Let's discuss about the degree. Let's first discuss degree of undirected graph. In undirected graph, let's say 1, 2, 3. So the number of edges from one node, for example, from 1 there are 2 edges, 1 to 2 and 1 to 3. That means the degree of node 1 is 2. Degree of node 2 is also 2. Now let's check it in the directed graph. Let's have a graph. In directed graph, there can be two types of degree. In degree and out degree. In degree is nothing but the incoming edges to node, and out degree is nothing but the edges going out from the node. For example, let's take this 2. So there is one edge which is coming from 1 to 2, hence the in degree is 1, and there is also one edge which is going from 2 to 3, out degree is also 1. For node 3, 2 edges are going out. That means for node 3, out degree is 2 and in degree is 1. Now there is one more terminology in the graph, that is path. So what is the path? Let's consider we have to start from 1 and reach 5. So how many ways we can reach? We can follow this path 1, 2, 4, 5. We can follow this path 1, 2, 4, 3, 5, and we can follow this path 1, 3, 5. So there are 3 paths from 1 to 5. So we can define a path as a sequence of edges connecting nodes. Let's say node 1 is connected to node 5 via this path 1, path 2 and path 3.